Today we're going to continue talking about percents, fractions, decimals, and then we're going to go into working on models of decimals. So last night you should have watched some videos about percents, moving from fractions to decimals to percents, etc. So this is going to be a table that we're going to put into our math notebooks as a resource. And these are really the fractions, decimals, and percents that your 7th grade teachers want you to know by next year. So these are ones we're going to focus on all year, and then you should really focus on over the summer. Some of them are really easy and you shouldn't need much memorization. You should be able to just utilize the strategies. Some of them are a little difficult and you need to just plain memorize them, in my opinion. The eighths, a lot of them need to be just memorized, like 1/8 getting to 0.125 and knowing that that's 12.5%. That's not an easy fraction to kind of move between for decimals, so that's just one that I would recommend you memorizing. 1/3 is a really common fraction decimal combination, and that's again one that doesn't move nicely and easily between each other. You just need to know that 1/3 is 33 and a third, and that decimal would be 0.3 repeating. So 1/3 is 0.3 repeating, and then it would make sense. 2/3, if you had two of that, 2.3 repeating, you'd have 0.6 repeating, or 66 and 2/3. So 2/3, 1/3, those are ones that I just expect you to memorize. 5/8, 0.625, just plain memorized. 3/8, 0.0375, memorized. The rest of them you should be able to kind of think and move through easily and quickly, and eventually you'll have them memorized and won't have to do the process. But I just wanted to go through working between these parts. This is going to be part of your test where they will give you either a decimal or a percent or a fraction, and you have to come up with the other parts. So make sure you understand how to do this fluently and effortlessly. If you don't understand, make sure you ask for further explanation. So right here, if I have 5%, I'm already thinking that that is 5 out of 100. 5%, 5 per 100. So that makes sense over here that it would be 5 hundredths, and then my fraction would simply be 5 hundredths. I can simplify that one to divide by 5, divide by 5. That would be the same as 1/20th. Right? 1/20th. So 5/100ths is fine on the test. You do not have to simplify it. If you can simplify it and you do, that just gives me more indication that you really understand fractions, you can move within them, and you can manipulate them. If I'm going with 10%, that tells me it's 10 per 100. The decimal is 0.1 or 1/10, but notice it's also 10 hundredths, like that 10%. So you can look at it as 1/10 or 10 hundredths. So our fraction over here can be 10 hundredths, or it could be 1/10. Again, that in the decimals, your place value dictates your denominator. So if it's 0.1 tenths, your denominator's tenth. If it's 0.10, your denominator's 100 because your place value goes to the hundredths. 1/8, we're just going to memorize that one. 2/10 or 20% could be 2/10 here. It could also be 20 hundredths, but simplified, it would also be 1/5. So that's a fifth that's pretty easy to manipulate because we can quickly get it to tenths or hundredths. So that's not one that you would necessarily need to memorize because you should be able to take 1/5 and get it to a tenth, which gets you to a decimal, which would quickly get you to that percent. 25 hundredths, 25%. This is a huge benchmark percentage. Again, make the connection to quarters. 0.25 is 25 cents. That's 1/4 out of 4. So watch this. 25 hundredths is the same as 1 out of 4. 25 cents out of $1 is like 1/4 out of 4 quarters. So again, that's a benchmark that you should be able to get from 4 to 100 pretty easily. It is one that we use a lot. 4 quarters in the dollar, 4 quarters in football games. 25% of the game, 50% of the game, 75% of the game, 100% of the game. If you can't skip count quickly by 25s, you need to work on that. 25, 50, 75, 100. Make sure you can do that easily. If we have 3 tenths here, that tenths and hundreds move easily between decimals. So 3 tenths would be 3 tenths. We could also have 30 hundredths, which would be our 30 hundredths. Then that moves easily into our percents because percents are always out of 100. So that would be our 30%. 1/3 is one we're just going to memorize. 1/3, 0.333 repeating, 33 1/3. 3/8, that's one we're going to memorize because we can't get eighths to be tenths or hundredths easily. So it's just one that we're going to memorize. 0.375, 37 1/2. And it's 37 1/2 because when we move the decimal, it's 37.5%, which is the same as 37 1/2. I didn't mention this, but I hope that you are writing everything down that I have put on my paper, you have put in your paper, so that you have it for reference. Here we have our 4 tenths. So 4 tenths, that's my denominator. So my numerator is 4. Simplified, since they're both even, we can simplify that to 2/5. So 2/5 is a fraction they expect you to know the decimal and the percentage for. But again, if you can easily convert it to tenths, then all of these things should come quickly. 1/2 is probably the most common benchmark that we use, and we're pretty good at it. 50%, which would be the same as 0.5 or 0.50. Again, we can connect this to money. 0.50 is like 50 hundredths, 50 cents out of $1. If I have 3/5 here, that doesn't convert to a decimal very easily, but if I take it to tenths, which is easy, 5 times 2 is 10, 3 times 2 is 6. So 6 tenths equals our decimal, 6 tenths. One of the most common errors that I see kids make is they'll see 3/5. They remember all of these ones that are kind of easy to do, 3 tenths, 3 tenths, 1 tenth, 1 tenth, and they want to go like this, 3.5 or 0.35. But let's think about that. Sorry, I have it over here. If we visualize and think through it instead of just doing the math, first of all, fifths are not hundredths or wholes here. 3/5, do your comparison. Is it almost none, almost all, or close to a half? 3/5 should be close to a half, because 2 1/2 is half of 5, so 3 is really close to a half. Is it possible to have 3 whole items and half of another one if we only have close to a half of something? No. Is it possible to have 35 cents of $1 if this is more than a half? Is 35 cents more than $1, more than half of $1? No. So then that should trigger your brain to go, wait, I don't do that. What do I do? Oh, I need the denominator be tenths, hundredths, or thousandths. So how can I get to those? Well, 5 goes to 10 easily. And then if it's tenths, 6 tenths, that means that it's also 60 hundredths, which means it's 60%. So basically what we've done on these ones that you need to memorize is we've taken them to thousandths. And that's the easiest thing to get 8 to get to the thousandths. And then it would be 5 times whatever to get us to 625. And that would be one that I would just memorize. 2/3, again, if you memorize 1/3 is 0.33, 2 groups of that 1/3 would be 0.66666. So that's that. 66 2/3. Making those connections can lessen what you have to memorize. Here we have 70%, so I know that's 70 out of 100. 70 out of 100 could simplify to 7 tenths, but it could also be 70 hundredths. And then my fractions over here would be 7 tenths or 70 hundredths. Either way. 3/4 is another really common benchmark that we need. 4 is easy to get to 100. Again, think about the 4 quarters in $1. 4 quarters gets us to 100 cents. So if I add 3 out of the 4 quarters and a dollar, I have 75 hundredths, 75 parts of the 100 cents that I need for a dollar. So my decimal is 75 hundredths, which then would make my percentage 75 per 100, 75%. 4/5 gets me easily to tenths, times 2, times 2, 8 tenths, 8 tenths, but my percents have to be out of 100, so 0.80, that's how many hundredths it is, so that would be 80%. 90%, same as 9 tenths or 90 hundredths. If it's 9 tenths, that denominator is tenths and my numerator is 9. So a lot of these are just simple. You should be able to understand what they mean. The decimals are out of tenths and hundredths, so are percents. So the fractions have to be out of hundredths or out of tenths if we can manipulate them to there. And then you can figure out the rest of them. And then there's just a few that you just have to plain memorize and get those in your memory bank. So that should be glued in your math notebooks as a resource if you need to find a benchmark comparison very quickly. Make sure you understand how to go from decimals to fractions to percents, because on the test they're going to give you one of the items and you have to come up with the other two. Okay? Next, we're going to move to how we can draw models of percents, because we're going to start problem solving with percents on Thursday, and it will be really helpful if we had some diagrams to utilize and pictures to use to solve those problems. So you should take this page here and glue it into your math notebook on your next available page, and pause the video until you have that glued down, and then you can come back and we can look at it. So now that we have this glued down, let's take a look at what it's telling us to do here. Sorry, my camera keeps wanting to pull on the cord there. Okay, so when you have a percent problem, like 30% off of $12, it is good to use these tape diagrams as our visual and plug in the numbers, just like we did when we were trying to solve ratio problems. Because remember, percents are simply a rate, they're a type of ratio, per 100. So first thing we need to do is be able to draw the models, so then we can use the models to problem solve tomorrow. So when you have a percent problem, tape diagrams are a great strategy to use. You want to use the most efficient model you can, and efficient means the easiest and quickest one to do. So when you're looking at a percent, think which would be the best first. So if a percent is a multiple of 25%, 50%, 75%, the best grid to use is a 4 grid. So just 4 boxes here. Each of the boxes is worth 25%. It's a 1x4 grid. It's quick to draw. It's easy to work with, dividing by 4s, and it'll be easy to problem solve like that. If your percent is a multiple of 20, 40, 60, 80, use a 5 grid. So again, just the tape diagram, I would do a 1x5 and just cut it into those 5 pieces. Each of the boxes is worth 20%. So this one is 20%, 2 of them would be 40%, 3 of them would be 60%, 4 of them is 80% of the grid, and then 100%. If the percent is a multiple of 10, we want to use a 10 grid. And notice I have 10, 30, 70, 90. I didn't put 20, 40, 60, or 80 in there because 20, 40, 60, it would be more efficient to do it this way than this one. However, if you had any multiple of 10, you could use this, and sometimes you might think you need this one and it won't work. You have to be flexible to be able to know, oh, I can also represent 20 down here in a 10 grid. So again, for a 10 grid, we just draw a 1x10 grid. Each of these boxes is worth 10%. So if I shaded to here, that would be 60%. If I shade to here, that's 90%. Each of these boxes would count for 10% of an item. Now you need to go to video 2 to talk about the other model that we can use.